This material is interpreted as water ice because its extent changes with time, consistent with slow sublimation caused by solar heating. By comparing this image with another one taken in July of 2016, we see that some of the ejecta blocks have vanished since then. It appears that fresh ice has been exposed on the east wall of the crater since 2016. This image was taken in the middle of winter in Mars' southern hemisphere and shows a crater near 37 degrees south latitude. The south-facing slope has patchy bright frost, blue in enhanced color. This frost occurs in and around the many gullies on the slope, and in other images has caused flows in the gullies. This feature looks a bit like a bear's face. What is it really? There's a hill with a V-shaped collapse structure, the nose, two craters, the eyes, and a circular fracture pattern, the head. The circular fracture pattern might be due to the settling of a deposit over a buried impact crater. Maybe the nose is a volcanic or mud vent, and the deposit could be lava or mud flows. Maybe just grin and bear it. Crater that punched through the surface of Mars reveals multiple layers formed previously below the surface. Half of the crater was then destroyed by the opening of the channel. Small craters pepper the ejecta blanket of the larger crater, but a few are visible in the channel, another clue to its younger age. The most recent signs of activity are the boulders that have tumbled down the sides of the channel. These craters may have bright ejecta from exposure of shallow subsurface materials below a thin dark cover. Most actively changing areas on Mars are the steep edges of the North Polar layered deposits. This image shows many new ice blocks compared to an earlier image in December 2006. An animation shows one example, where a section of ice cliff collapsed. The older image is not as sharp as the newer one. It shows an area near the sand sea that is surrounding the water ice-rich layered deposits. The many bumps are sand dunes, less than 100 meters across, that are mostly covered by seasonal frost, appearing in a manner that looks artificial, but is a natural consequence of the wind patterns in this region. The smaller, darker spots are places where the seasonal frost has sublimed away, exposing the dark surface below. The combination of these features makes for an unearthly scene. This review shows that the rock has a range of textures, from massive and fractured on the left to subtle banding or layering on the right. The origin of this mound is unknown, but its formation may be related to the clay-bearing rocks in the nearby Oxyoplanum region. This meteorite hit a dusty area and made a crater, but did something a little more special to the surrounding dust. We can see dozens of dark, dust-free streaks on slopes surrounding the crater. These slope streaks form when dust slumps downhill and happen naturally on a regular basis. In this case, though, the impact and explosion that made the crater seems to have set off many of these downhill slumps of dust simultaneously. This could have happened from the explosion's blast wave passing through the air or the shaking of the ground that it caused. This ejecta shares similarities to others found elsewhere on Mars, which are of particular scientific interest for the extent of exposure and diverse colors. The colors observed in this picture represent different rocks and minerals now exposed on the surface. Blue in high-rise infrared color images generally depicts iron-rich minerals like olivine and pyroxene. Lighter colors such as yellow indicate the presence of altered rocks. Its impact crater looks amusingly like a tadpole because of the valley that was carved by water that used to fill it. When the water level inside the crater increased, it breached the crater wall, flowed outward, and formed a valley. Sometimes the water may flow in the opposite direction, like from a channel into a crater. Streaks are often diverted by the terrain they flow down. This one has split into many smaller streaks where it encountered minor obstacles. These streaks fade away over decades as more dust slowly settles out of the Martian sky. Rather than a single impact crater, we see multiple impacts like a shotgun blast. This suggests that the impactor broke up in the atmosphere on entry. Our image depicts 21 distinctive craters, ranging in size from 1 to 7 meters in diameter. This color image reveals bedrock that is several kilometers below the top of the giant Valles Marineris canyons. The upper layers have relatively little diversity of colors and textures, but deeper levels show more complex processes. The upper layers could be mostly volcanic, while the lower layers were influenced by the period of heavy bombardment and greater interactions with water. a new, dated impact crater that triggered a slope streak. When the meteoroid hit the surface and exploded to make the crater, it also destabilized the slope and initiated this avalanche. The crater itself is only 5 meters across, but the streak it started is 1 kilometer long. Slope streaks are created when dry dust avalanches leave behind dark swaths on dusty Martian hills. The so-called Swiss cheese terrain, referencing the numerous holes of the region, is a product of seasonal exchange between the surface and the Martian atmosphere. With a predominantly carbon dioxide content at 98%, the colder temperatures condense the gas out of the atmosphere to produce dry ice. The prevalence of water is more concentrated in the north, leaving the South Polar region more carbon dioxide rich, and it's this difference in composition that generates the unusual texture of the Swiss cheese terrain. Polygonal patterns form by winter cooling and contraction cracking of the frozen ground. Over time, these thin cracks develop and coalesce into a honeycomb network, with a few meters spacing between neighboring cracks. Shallow troughs mark the locations of the underground cracks, which are clearly visible from orbit. Blue appearance is due to the intense blast of the impact moving around dust on the surface. That dust is usually light-toned and reddish in color compared to what's beneath it. This bluish blast zone is very different than the exposed ice some new craters dig up. The shape, color, and brightness are distinct, and tell scientists this is not ice. Blue and green colors are generally due to mafic, magnesium and iron-rich minerals that are not altered by water, while the warmer colors are due to altered minerals like clay. The structure in this scene is quite complex from a combination of impact and perhaps fluvial and volcanic processes, tectonic faulting, and erosion. The terrain is very old and has experienced a complex geologic history. The light bluish boulders on the slope appear to originate at a layer of bedrock, also light blue, near the top of the section. Second, the dark thin lines are recurring slope linei, probably also due to mass wasting, but composed of finer-grained materials. The dark lines swirling over the surface of the dunes are tracks of the dust devils. Dust devils are whirlwinds that pick up the light-colored dust on the surface as they move around in odd patterns. The lines visible on the dunes are the dark sand left behind when the surface layer of dust has been removed. This area was previously imaged in August 2009, about 2 Mars years ago, and in that image, dust devil tracks were also visible. However, the tracks visible now are completely different from the earlier ones. This tells us that there has been at least 1 dust storm since then to erase the old tracks, and lots of dust devil activity to create the new ones. We can also see dark linear streaks going down the slopes of the dunes. These features are caused by some sort of flow down the slope of the dune which strips away the light surface layer of dust. In 2009, similar streaks were observed on the slopes of the dunes. However, they were different from the ones which are observed now. Thus, the flows which are causing these streaks are still active today. These cones could possibly be mud volcanoes. On Earth, a large number of these formations are located in Gobustan, Azerbaijan, and the Caspian Sea. If they are mud volcanoes, what are the processes on Mars that might have created them? At high-rise resolution, we can look for subtle flow features and compare these with other cratered cones elsewhere on Mars.